Right, so I see we have 6 people on the audio channel. Yay! So you've joined early to listen. Hopefully I've started streaming now as well. So when we stream this, I have both my Discord channel open and the YouTube channel open. Now some people will watch YouTube and listen to Discord, or listen entirely to YouTube. We're trying to get the audio about the same, and it seems that my YouTube audio is going too far into the red, so I've decreased that a little bit, so hopefully that'll not blast out quite so badly. And I will minimize that, and I appear to be live in YouTube with 5 current viewers. That's excellent on a Wednesday morning. And if you are following me, then you can come and chat on the Discord channel for the course. Otherwise you can, as someone has done, say good morning on the YouTube. I'll try and bounce back and forth whenever there are questions. So if you need a group, we're willing to be yes, excellent, yay. Carl is offered to do the review, which is great because I've been looking forward to doing a code review. So today we have a couple of different options for the lecture. I have in the background here the Git and semantic commits as a possibility, because I realized I'd talked about them a few times, and I've kind of quickly shown you at the beginning of various talks because I've been using them, but I thought perhaps I should actually go through some slides so you actually had a slide deck to actually see this stuff, and I can upload this into the GitLab repo so that you can have it when you need it. So it's on hand as well as viewing the video. So I will just go to the GVK site, there we go, and upload that. Now, we start at about 1:15, if my memory serves me correctly. So I'm just sort of doing the introduction at the moment. I will try and answer some questions, and we'll see how this code review does with Carl's group. Now I will just get my repo version of that up, which should be in the IMT3602, and that is Carl, and here's the first repo link of the 3, which is excellent. So I can also, in theory, view this code. Now, this is doing a code review of a third-year project. So though I believe Carl was suggesting that this had been done for the 3601 course, the 3601 rather than 3602, which is the game programming course. So Carl will be able to tell us more about it when we get there, and also I will bring up his code locally so I can view it, and I'll pull it down so that I can view it in Visual Studio on my local machine, which will make it a little bit easier. So if we're hopefully all online and ready to go, we can start talking about some version control stuff, and I can pull down this repo while we talk, and that way I'll have it in Visual Studio. Right, so today I was going to talk about version control, and I'm assuming, because we've been pushing Git very hard for a long time in Yervik, that you guys have a well-developed and keen appreciation of Git and all things Git and version control. So what we might have to do is I might have to, on Discord, actually ask that question, because we can ask how comfortable are people with Git and with version control, particularly with Git. So some of the international students may not have used version control very much, We've been using version control for a very long time. Oh, that's new for me. I've just been asked by Git Credential Manager for Windows to enter my credentials for the Git GBK. Alright. Yes, get rid of everything, just start again, reset hard. Right, I see you guys are fully up with the I don't know how Git works, so I'll just destroy everything and start again from scratch. Unfortunately, often when you get caught in nasty merge conflicts, one of the only ways to deal with that is to just get rid of everything you've done and go back to the remote version. So there's a few people who are saying they're reasonably. Yes, I also hate the Windows Credential Manager. This is my first time that it seems to have decided that it hates me. So I have to remember what my login for that particular version control system is. Half the time I probably won't get it right, because I know I use different passwords for different locations, and so I have to try and remember which is which. So we'll see what happens. Nope, got that wrong. I'll just see if I get it right at some point. 3602 and 2018. Right, 2020. We're already 2020. 2020, right. And select folder. /her. Yes. Where are you now? Right. Okay. So I'm cloning the repo from Carl so that we can do a code review with it. Yes. Fix the LFS. Excellent. Right. So now that I have that, shall we continue with? And you guys have given me a various answers to your level of comfort with Git. So what we shall do, and you can see here that it's bringing, right, there we go. I can bring back the lecture slides. Right, so let me actually go through a more normal lecture style for a few slides, and quickly talk about one of the things that I think is different once you become a professional than you do as an amateur, and this is to do with the way that you use Git. I call them semantic commits. Now this is my term, so you won't see it being used out in the real world very much, but it's this idea of moving away from just committing everything and getting it out and getting it done, and actually having meaningful commits. So what I mean by this is the move into smart commits, where you actually attach links to issues, and potentially with Jira you can actually, in the commit message itself, link into control the project through the issue tracker. And the difference between that and temporal commits, and the difference between temporal commits and smart commits. Okay, so all of this is part of what we talked about earlier, which was automating processes, and we talked about continuous integration. There are I have a YouTube there if you want to have a look at what I was doing in ECS, which is my group here in Wellington, on version control. Now I've got some, I'll try and turn that down. write it down. Okay, so and also this idea of automating testing and regression and test-driven design. Now, so we've talked a wee bit about regression testing, this idea that you write tests, and once you commit messages, you test that the program still works, and when you optimize, you check that it still does what it used to do. And that's partly what we do when we're doing code reviews and refactoring, as we talked about last week, is we do that regression testing. Now that all comes as part of the code control. So if you're going to do the work with version control, then there are some assumptions. So I have to assume that you guys are familiar with Git and distributed version control systems. Now, some of you will not be, potentially, if you're international students. And if you are in that situation, then yes, you will have to go and read a bunch of stuff about version control and go and read about Git and get yourself updated on the standard flow. I'm also going to assume that you have projects with issues to solve. Now, for all of you working in your bachelor theses, these are very clear. You negotiate those issues, you put them in, you have milestones. We want to record information at the time it was created. So for your bachelor thesis and for any large project, often you'll be asked to give reports about what happened and when it happened. If you wait to the end of the project, it is extremely hard to remember what happened when. And so if you can note things down at the time they happened in your commit messages, then you have this kind of temporal record of the process and the project. So if your project requires some sort of reporting at some point, then yes, and recording information at the right time is important. Logging of progress is important. So if you're in a project where they don't care how you get to the final result, they just want to see the final result, then no, maybe you don't need to worry about your commit messages in your version control tool, because the people who are paying you don't care. They don't want to look at it. They really don't care about any of that. That's fine. That means you don't have to do this. However, for your own sanity, and if you are trying to be professional about what you do, then you probably do want to log your progress so that it's easy for you to look back and make estimates and correct your scoping. One of the things that a lot of our employers talk about is the lack of scoping ability in our students. And that is because we tell you guys how big an assignment is, and we give you a certain length of time to do it. Given that you've only got that length of time, you can work out, okay, this is a 2-week assignment, therefore it will take 2 weeks of work in this class, right? So that means that you've got a tightly defined scope for your assignment. Now that you're on a really large assignment and you're starting to become professionals, you are expected to work out the scope of the challenges you're facing. Now, one of the only ways to improve is to write down your estimates and write down how long it's going to take you. That's why in GitLab you have each issue has a /estimate, and that allows you to guess how much time each issue is going to be. We expect that you get that radically wrong every time you do it, because everybody is terrible at estimating how long a task is when they first start looking at it. Over time, you can get better, but you can only get better if you actually write down your estimate. It's no good thinking about how long something will take, then just giving it a go and you know, if you wrote it down, you say, right, this will take me 3 hours. And then, you know, at the end of 8 hours, you finally get it done. If you've not written down the 3 hours, by the time you've got to the end of the 8 hours, you probably think to yourself, yeah, no, I did think it was going to take about 8 hours. And so you think your scoping's fine. The answer is no, your scoping is still terrible, right? So it is very important for you to actually write down this. And that's why progress logging during version control and putting those estimates onto your issues is really important. We also make an assumption that good logs create easier debugging. It is amazing how often you have to trawl back through what code you wrote to find bugs. And if you know why you wrote something and when you wrote something, you could usually find a good way, a faster way of debugging it. Okay, now Git, simple overview. It is a distributed version control system. It uses what's called change sets rather than versions. What that means is, rather than actually storing versions of a file, what it does is it records the changes between files. And it looks at those changes, and it can actually merge and rebuild those changes, and it puts them in and out of sequence. And so at any stage, you don't actually have a version of your file. What you have is the current reconstruction from all of the change sets having been applied. So if you want to go back into the history and alter something about the file, you can actually go and remove parts of the change sets, and it can fast forward them by incorporating a whole bunch of versions from one side and putting all the new changes in front of those. So rather than think of these as version A and version B, what it actually does is says, well, actually this is a change set A and change set B. If I apply A before B, I end up here. If I apply B before A, I end up here. Does that matter? If it doesn't create different files, then you can merge them either way and it will work. So there's a bunch of processing going on that it thinks about in change sets rather than versions. That's actually a very different way of thinking about your file, rather than saying, oh, I've got a version of it and you've got a version of it. It's that I've got a set of changes, you've got a set of changes. Which of these can we apply? We also think that each change should have a reason. So this is partly why Git makes you write commit messages, is that it wants you to give a reason for why you're touching code. We actually like with GitLab, it then has issue trackings, and although original Git repositories don't have an issue tracker as such, very quickly those commit messages were being used as reasons to make changes. And now all the major GitLab, or Git rather, providers have some sort of issue tracking. So GitHub has it, GitLab has it, Atlassian, Jira has it. All of those standard tools you use with Git come with issue tracking, because it's so fundamental to working in Git, is this idea that you have commit messages and those commit messages attached to issues. That's why we have the reasons can be tracked in issues, and each issue has a bunch of information attached to it, right? So if we actually have a look at the various providers, so GitLab, Bitbucket, GitHub, all of these have this concept of an issue tracker. In Bitbucket, it's part of the Atlassian toolchain, and the Atlassian toolchain with Jira has much larger and corporate level tool tracking and integration. So it actually does a lot more in your commit messages into Bitbucket and Jira than you can with GitLab and GitHub, but the concept is relatively similar. So here in Yervik we are using for GitLab the Git GVK IDI and ntnu.no. That's our server. Hopefully you're aware of that, because that's where we're hosting this course. Now we actually have the enterprise server, and we get that as an educational discount, which is why it has all of the features of a GitLab server rather than the restricted version you get if you just install a free server. The CLI versus command line. Now Mariusz and I have a friendly argument about this. He is 100% command line. Nothing ever happens in a GUI. All GUIs are terrible. Never use a GUI. I'm more of I'll use command line when I need to, and I'll use a GUI when I need to. And sometimes source tree does things more easily than the command line. Sometimes the command line is more exact in what you do. So I'm happy for either of you, either tool, for you to use either command line or something like source tree. I've found that source tree tends to be, for my mind, the best of the GUIs. and there's one specific feature that I find much easier to do in source tree than in command line, and we'll get to that. So this is an example of what a source tree version control view might look like. So as you can see, we have the commit messages. This one doesn't have smart commits because it doesn't have any of the hash numbers associated with it. But here you can see there are multiple versions coming in. People are integrating their work on different branches. There's an original name fix, an original name fix, and an image avatar are two different branches that have been being worked on. And there's also a master branch which has not been updated yet, right? So you can see down halfway down this list, there is a master, original slash master, and original slash head. That is where the current master is, and that's the yellow. Now there's a previous branch that is earlier, which is one step earlier. And there are these other branches that have been made where people have been editing, and various out of sync issues. So this is an example we might see in source tree. It's useful to get an idea where everything is visually, so that you don't have to kind of scan through the command line text as you go. Now, one of the things I will show you, and I'll bring up source tree later, is this idea of semantic commits, where you actually do selective staging from within files. Now you can do this in command line, where you do interactive staging, but it's far more challenging in command line than it is when you have a GUI tool that does it for you. So if we have a look at the idea, I mean, I have not seen any more questions, and you guys seem to be following along still, so this is going okay, hopefully. It seems that you've not got any other questions. No, that's all good. I just thought I'd check all the questions to see that we're on track. And oh, I need to go back to, where did it go? Oh, there it goes. Okay, so a standard sequence on an existing repo. The very first time you do it, you do git clone the URL. Otherwise, you do a git pull. And now you should do a git pull every morning. Every morning you come and do the git pull. This is a routine so that you decrease the chance of being out of sync with other people. Everybody should do a git pull right in the first thing they do in the morning, and then if there are clashes and there are merge issues, then yes, you should deal with them before you do more work, right? Because if there are issues with your pull, right, then you need to sort those, and they're going to have to be sorted at some point, and the more work you do, the harder it will be to sort them. So do them as soon as they occur rather than wait. You then edit and add new files, and if you've added new files, and this is something that people forget to do quite regularly, is the git add for, and here I'm saying git add star, that would add everything that currently hasn't been added. You may not want to do that, but you certainly want to add new files that you want to push the repo. Many times, standard problem, people do some development, they edit some files and they'll add a new file, and then they'll push, everything's fine, except the new file they created hasn't been pushed, right? Because it hasn't been added, so it doesn't get pushed to the repo. Some people are quite good at remembering, their IDE helps them to remember this with code files. So you're in code, it's all good. You add a new code file, and your IDE says, oh, this is a little red tag next to it saying needs to be added. You then click add, it adds it, so now it's got a green plus next to it, and then when you commit, yay, it's been added, and so you commit and everything's lovely. However, often the version control tool, your IDE with your programming in, will not have images in the IDE. So any images you're adding to a project, particularly textures for a game, for example, you have to manually remember to do those because your IDE doesn't have those in the list of files and the list of sources, and so it doesn't remember that you have to add that, so you have to remember. So be careful when you do that. Often then when someone pulls the project, something's missing, and it's kind of, oh, what's this missing and where is it, and you go back through it, it's working fine on my machine, why is it not working on your machine? Right? So all of that becomes a problem. We did have some problems with OBJ models. So some of you will have used OBJs in second year, which is an object format for a very simple object notation. Right? It's great for sending objects between groups, because you can read kind of the object format because it's in a very raw format. The problem with OBJs, and some of you may have come across this, is in the standard C++ gitignore file, OBJ, which is an object file created by the C++ compiler, is explicitly removed from merging, which means you put in some OBJ files and then you add all the files and it doesn't add the OBJ files because they're in the gitignore, and then you push and everything pushes up and it worked perfectly on your machine, and then you go to someone else's machine and you don't have any of the characters, and it's kind of, where did the characters go? Because they're in a gitignore. So those sort of things do happen. You need to be aware of them when you're using Git, and so when you do git add and when you do git commit, you actually have to make sure that you are actually adding all the files and they're not being ignored. We then have in command line git commit -m message, and then git push. That is our standard. I'm hoping all of you are doing that, or a version of that. Okay, so right, is there not an argument for pulling when whatever you are working on at this second is done, so you have a better position to verify the pull hasn't messed something up? So you have to pull in the morning. You could also pull whenever the thing that you're currently on is working on has compiled and worked. It is reasonable to commit that then and then pull, right? So rather than necessarily doing a pull before you commit, because it should complain at you that, hey, wait a minute, you've got uncommitted changes, and so what you do is once you've got it working locally, you commit. Now you've got to remember, commits work locally, and so then you pull from the remote into the local and do that. Now, one of the things I don't have in here, and is something you can do as a version control system, is the pull-only version control approach. Have any of you heard of pull-only? So pull-only Git is the idea that nobody has push authority on the main repo. Right, so it is no one gets to push to the master, the remote, the central repo. Nobody pushes to that. Everybody just makes pull requests, and then on the master you do a merge with pull request. Right, so you don't ever do a push. You only ever make pull requests. Which means that you then have to go into the master and accept a pull request to do an update. Now this is partly done to prevent anybody being able to make massive changes, right? It requires someone else to verify what you're doing and check what you're doing. Now it's a slow way of doing things, but if you have a very stable code base you really don't want someone to edit, then you can turn off push to a repository so that nobody can push anything ever, and so everybody just has to make pull requests to each other, and so when I am updating my code, I don't push to the repo. What I do is I create a pull request, and then I make my repository available so it's visible, and the person then in the master repo goes and has a look and accepts the pull request by then being able to see my repo and then pulling in all the content. This is, yes, a different way of managing issues in Git, but it is a technique you use. If you look at pull only, you'll find some discussion around it. Some of you are working in Unity. How many are working in Unity? I knew there were at least one group who was working in Unity. So there are some issues as well with working in Unreal, particularly around large code bases, and both Unity and Unreal have issues with their scenes. Now, blueprints can be an issue in Unreal, and scenes can be an issue in Unity. So what you have to do is do quite a bit of reading on no, I didn't mean to do that. That's the Karma page. You can go and have a look at that, but I accidentally clicked on there. Right. So if you're using Unity or using Unreal, go and have a look at git ignores for those two systems, and git ignores for whatever engines or libraries you're using. It is important not to flood the Git server with a whole bunch of useless binary files. And this is also why we have the LFS system. Now, I see that in the repo that Carl is using, that we're going to look at later, he actually does use the Git LFS so that we have a large file system which handles the binary files and large files differently to the way it handles text files. Most of your code is text files, so it gets handled differently, and that makes it much better. Now, I have a link here which I'll upload if you guys want to watch the YouTube videos, which those were made for me, showing my students in New Zealand some of how this works, right? So that's why that link is there. So Git commits. The idea in a commit is there's a stage, a commit, and then a push. Now, if you're making an interesting commit to your repository, then what you'll get is you will stage, and you'll jump in there and you'll stage. You'll say, all right, I'm ready to make a commit, and so you will stage all the files that you want to add to that commit. Now, often we just do stage all. And so the idea is that all of the changes get put into the stage, right? And if you just do a standard git commit without staging anything, it will just assume that you're staging all changes and stage them all. That's not always what we want to do. Sometimes we want to only stage some of the changes. Rather than commit all changes, we want to commit just some changes. And this is where I get into this difference between time-based commits and semantic commits. Now, time-based commits are what many of the students do, which is that they commit at the end of the day, right? Because they're going home and nothing's working, but they do a commit, and they do a kind of, commit, they push their branch, and then they go home. Now, and so that when they get home, they can then do a pull and keep working. Now, you should never do that to master, because if you do a timed commit to master, basically you could be breaking things for other people. And so if you're going to do a timed commit, try and always put it on a branch. And then, if you need to, once you've branched, temporal commit, so committed versus the time, you get home, you pull that branch, and you then get your work done. And then you merge that branch back into development, or back into the feature branch you're working on, or back into master if you've working that way. So try not to put time-based commits into the main branch, right, or into your feature branches, because a timed commit doesn't tell you anything, and B, can break the build at those times. So try and avoid those, except by creating a new branch and using a time commit. Mostly what you want your commits to be are commits that solve a problem. Right? Now this is very hard to do because instead of having multiple hashes associated with multiple issues, what you have to do is say, okay, while I was fixing this part of the code, I found a bug, and normally I say, oh, okay, I found this bug and it solves a whole, like, you know, okay, I found this bug, oh, I was reading through the code and I also saw this thing that I fixed. Now, I've now fixed two parts of the code. So the thing is, if those are different issues, I can't just go like hash 34 boundary conditions added, because if I've also fixed up something to do with issue 12, then I've now got two issues that are the same set of code. Someone who has a problem with issue 12 doesn't want to have to look at all of the code associated with issue 34 when they need to fix issue 12. Right? Now, if I include both of those hashes, hash 12 and hash 34, in my git commit, then I will confuse whoever is trying to work on my code and using the commit messages to track down where things are and why they are what they are. So what I then do is I need to use interactive staging. So interactive staging, and this is an example here in GitLab, in source tree rather. So here what I'm doing is when I stage a project, you can see we've got the unstage all and the unstage selected and stage all, and off to the right hand side we have something called the per file staging area. Now in that area you can see that I've got one line that's being changed, which is the associated engine with this Unreal code, and it goes from 18 to 20. Now that has a hunk 1 associated with it. The idea here is that I can choose parts of files to stage. Because if I've been making an edit and I've edited a whole bunch of the file, I may look at it and go, only some of those were related to this particular edit, some of them were related to another issue or some other thing I was doing. So what I'll do is I'll just put those two as separate commits. I'll go in there and I'll just select the particular lines that I want to add. This also works when, you know, I'm working on a large feature. As part of working on that large feature, I suddenly realize that our math, that some of the math is wrong in one of the functions, and I go, oh shit, I have to update that. I update that math and go, oh, everybody should get the math update, but they don't need all the other updates that I've been working across the whole file, because those will change functionality. So what I do is I don't stage the whole file, I just go in and interactively stage just the math function that I changed and updated, and I then commit just that function with an issue around improving maths. Right? Now, at that point, I can see just the math function has changed, and I don't have to think about all the other stuff. That is what we mean by a semantic commit. The commit is internally meaningful. The commit message actually tells you what happens with all of the lines that have changed, not just fix some stuff, or as you'll see often and get updated home, and it's kind of, well, yes, you've updated the home page, but so that idea that I'm actually trying to have meaning attached to those commits rather than just be a logging of my progress. I actually have a semantic meaning, and that actually makes tracing what's going on much easier. Now you can do, and the link here to the Git SEM book actually shows you how to do interactive staging directly in Commandline. I much prefer to do interactive staging in source tree because I use the file viewer on the right hand side. It's just a lot easier for me. But you know, if you like Commandline, then you know you like Commandline. Okay, so we do have some comments. I see people have been talking rapidly. So alright, gitignore.io is great for that. Right, so on Unreal they're just chatting about gitignores. Thank you for adding gitignore.io, which gives you a list of gitignore ignore files for different types. there's also a drop down in GitHub that allows you to add the right kind of gitignore, and their templates, sometimes you need to update them. So as Thomas has suggested in the Discord, if you have things, this is often for any configurations. He's talking like a password JSON. I found this true for any time I'm doing a database. If I haven't got something related to a database, I'll put my database config in a separate file, and then I will add that config file to my gitignore, so that I don't just push up my private passwords for my database login to the remote server, right? So it's just good practice to keep your passwords in a gitignored file. And so if you're, because when you do a database and you're doing, the code around an SQL lookup from within, say, PHP or JavaScript, and you have to store the database logins for your local database in the config, you don't want that on the version control server, particularly not if it's a public server. So you have to have a dummy config file, which all of you know is a dummy file. So when your collaborators pull the repository, they'll get a dummy config file, and then you have to separately tell them what those passwords and what the details for that config file are. Yes, it's a hassle, but it certainly improves the yes. Yes, pushing up the bot token is hilarious. So people will do this. They'll often forget to remove or put their config information in a separate file and then gitignore that file. So just to be aware of that, and that's also part of this being a professional and remembering those things, right? As an amateur, and a lot of people making bots are amateurs, you will forget these things. Okay, so the principles behind using semantic commits are that you are documenting what you're doing. Separate code changes, so separate code changes at the time you're changing them. So when if you've been making lots of changes, you then separate them out and commit them one after the other, right? So this might be multiple commits, each with different messages, each talking about a different bit of code that you've changed. And that's just about tidying up your process. And you don't want to really have to go back through and do this later. And this idea is that the additional time spent during creation saves time on maintenance. Right? And because we know that maintenance is the largest part of real professional work, is maintaining and debugging code, much more than creating it, we don't mind the fact that we're adding a little bit more cost to creation to improve our maintenance and debugging. Now, as I said, there are smart commits. In GitHub and GitLab, you use #34 or hash and the number of the issue. And if you want to know a good way of remembering what number of code the issue you're working on, what you do is before you start editing code in the morning, you go and have a look at the issues that you've got on your to-do list, and you go, right, I'm going to start work on issue number 10, and this helps me. You say out loud the number 10 just so you hear it, if there are other people around and you say, right, issue number 10, they may even overhear you and go, oh yeah, that's right, Simon's working on issue 10. But just being able to say that name means that when you get round to committing it, you've hopefully remembered, oh yeah, I was working on issue 10, right? So having that number means it's easier to write the issue down. Now, in Jira, you actually have a short name for the project, followed by a dash and then the number of the issue in that project. That's because you can actually have repos associated with multiple boards and multiple issue trackers, and so it needs to know which one you're referring to, and so it uses a slightly longer form of the issue number. And also in Jira, you can do much more intelligent things to those issues. Right, so you can actually add your time that you've worked into the commit in Jira. You can change things about it. You can change who owns it. You can change what stage in the process it is. So it goes from being doing, say, so you're currently active, to in review, or external review, or whatever the next stage is. You can actually move an issue around associated with that code just directly in the commit message. When you write issues in GitLab, you have a title and description. You must have those. You can also assign it to a person. This is quite useful because you get to see, when you go and look at yourself, you get to see all the issues that have been assigned to you. Creating a due date tells you when you think it needs to be due. Attaching it to a milestone suggests that there is some process that we're following which has milestones, and try and give it a weight. And what I didn't say here is if you want to improve your scoping ability, give it an estimate of how many hours it will take. Sometimes that's directly associated with weight. Sometimes you look at the weight as a complexity, and then you try and guess the hours as how long you would take to solve the problem. So those can be separated out. This then gives you things like a Burndown chart, which you can go into your GitLab and have a look at your Burndown. Ideally, you would have burndowns that look a wee bit like this, that actually, the number of you are actually actively making progress over time. Very few Burndown charts look like that for new developers. So don't be upset if your Burndown chart never looks like this during your bachelor thesis. It will take time before this is what your version control would look like. We also do some interesting visualization of version control. Now, I would be interested in discussing with you as a class which tool you'd like me to look at to assess your version control. Now, Git Inspector is one that was developed by the Swedish and is quite good for seeing who's committing what and how much people are committing. You can see this is actually the Git Inspector of I think it's the graphics code, where I started the code and wrote the template, and then PM Orton did the majority of development. And you can see how he's the yellow there, and he's done most of the work, and I did a small amount of work. And so that's one way of looking at a repository. If there's multiple of you working on it, you get each person's segment. I don't know, have any of you seen Gorse.io? I'll put the question mark, Gorse.io. I quite like it. It's and I've spelled it incorrectly because it has a U in it. Gorse.io. If we look at that, and I'll just check the stream is actually following. It is following me. So what Gorse does is you can actually, it animates your version control tool. So you can point it at a particular source, and what it will do, and you can download this and think, is that as a person here, and as a person is there editing files, you can see which files they're editing, and you can see the relationship between those files in terms of folders, right? So these are each of these are folders, each node is a folder, and the files are the files in those folders. And these are people going through, and it's animating over time when they touched different files, right? And where the activity is, right? So the bloom effect here is if there's lots of activity, it glows more, so you can see where the majority of changes are happening. Now, it's cute, but it gives you kind of that visual representation of where people are moving around within the files and within the folders, right? And that can be quite a nice way of getting in your head what your project looks like. So if you want to, you're just starting, but you could apply you could download Gorse and then point it at your repository, and it will make these pretty animations for you, which is just a fun, nice way of seeing things. So not necessary, but it is quite nice to be able to. Oh, I need to actually stop that. It is quite nice to be able to see these things in an appropriate way, right? Or in a fun kind of way. Okay. This will also allow me to look at kind of the contribution of people and see where things are, and see that visual of your repo. So if you like it, use it and submit it as part of the reference. Now, last week I also mentioned the word or the GitLab Blame feature. Git Blame is great if you've been doing your good commit messages, and with links to issues, it shows you who did what within a single file. So that actually does help me. I've used that as a marker to actually go and look at code and work out, okay, this person says they've done most of the code. What do the commit messages tell me about this code? Right? Because sometimes people say, oh yeah, I did lots of it, and then you actually go and look, and they didn't actually do very much. So actually seeing the history of a file can be quite useful, and so that's why it's also important to make very specific commit messages. What we want you to do is I want you to use issues, right? So if you're not currently using issues in whatever version control you're using, do it now, because that will be part of your grading at the end of this course. I want you to work on making your commit messages more meaningful, and I want you to at least use those hashtags to hash link them to the number of the issue, right? So I want to see that. You can use quick actions in your issues to change the issues, the estimates, for example. Quick actions do a lot of things. You can, if you're really keen, find APIs that will allow you to access GitLab and access the quick actions, and you can use tools to update things from mobile phones, for example. There are a few of those. I want you to write in Markdown. Now, I'm not hoping I don't have to teach any of you how to use Markdown. You should know how to use Markdown. So that's what I want you to be at least able to do that. And also the wiki is in Markdown. So think about what things are kind of directly related to code, and things that are more general project that don't tie to code, and they might go in your wiki, whereas general specific things associated with code will go in the README. And this is all about, when you write these comments, you have to think about me or a maintainer who is reading your README and trying to understand what your project is doing and how you've achieved what you did, because I'm a reader, I will be having to read this. So it's not just for you, it's for someone to help understand your code. I had an old professor, the way that he did READMEs and commit messages was that if your code worked perfectly, he didn't care and just gave you full marks. If it didn't work, he would then go through and fix your code, and however long it took him to fix your code is how many marks he took off you. So that's a good way of thinking about code, to say, yep, I want to write code and write comments that are good for the person who is trying to fix my code or maintain my code. You will have merge conflicts. The more often you integrate, the fewer merge conflicts you have. I like using a visual merge tool. Command line merging, very tricky. For Windows, I quite like WinMerge, but that's my own preference. There are different diff tools for Linux there that you can go and use. Work on your branches rather than on the main branch, right? So actually create branches where you are isolated from other people's changes. And for Unity specifically, is that you don't have two people working on the same scene. In Unreal, don't have two people working on the same blueprint. Unless in Unreal you're doing the clever thing of having a multi-user editing where one person becomes a server, other people log onto that server and can edit the code simultaneously, right? You'll also notice if you're working in Visual Studio, the latest Visual Studio build has simultaneous editing mode as well, and that allows you to simultaneously edit the same files using Visual Studio. It's read commit messages. If it saw that string in your Git commit, it would go, aha, that does something, I know how to do that, and it would trigger something. So you can actually set those up yourself. Now, of course, that's how hashtags started in Twitter, is because people wanted to communicate with each other, but they didn't have any formal system for doing this, and so people used a hash and then a name to try and say kind of a topic search, and then people would search for the hash and the topic, and then Twitter went, that's cool, let's make that normal. And so you could then search for hashtags rather than just searching for text. But it was very much a user-created way of documenting things. And you could do the same with any webhooks. You could have special hashes. It's kind of where the hash number comes from for issue tracking. Deployment to web, automated testing, you should be starting doing this. I know some of you have started playing with integration development, the continuous integration in GitLab. If you haven't started doing that, do start doing it now. I would like to see some experiments with that, if not full use of it during your projects. Okay, so I was going to end there as being about an hour of me talking, and then we can have a short break and get down to some code reviews and reviews of coding styles or reviews of commenting styles. And you guys can probably have a small break. We'll give you a 5-minute break to get up and walk around, go outside, come back in, get yourself a cup of coffee. I will go and get myself a cup of tea, and then we can come back and continue with a code review. Does that sound like a reasonable thing to do? And we'll go and check on the Discord. Was the stream, did the stream go down, did it? Oh, rest in peace, stream. Okay. My stream seems to be back up for me now. Okay. Sorry that the stream died, everybody. Hopefully it's back up now. Oh, good. Okay. So what I was saying is let's just have a 5-minute break. I'm going to go get myself a cup of tea, and then we can come back and do the code review, if that makes sense. Now, do I have Carl with a microphone here? Let's see, it was Carl, wasn't it? Yes, Carl. Carl, do you have a microphone? I can see you at the top of my lecture list there. Yes.
Yes, there's a microphone here.
Okay. Now I need to go like that and see if... Right, can you say that again? So I'm just seeing if we have echo. Okay, Carl, can you say something so I can check that my headphones are working properly? Yes, people need to jump on that unmute button. Yep, no, Carl has unmuted himself. That's all good. All right, I'll just go make myself a cup of tea. I'll be back in 5-10 minutes. I'll leave the stream going because you guys are watching and I don't want to stop the stream and then have to restart the stream in a few minutes. So I'll just leave it running and I'll be back in a few minutes after I make myself a cup of tea.
Whoa.
Right, back and rearing to go. Excellent. Okay, I'll just put these on so I can hear people. Right, okay, we're all ready and back. Aha, I can see myself walking in. Okay, so if I go to my source tree, and I go to, right, I think I have the latest version, and I have a sprite renderer and head. I think we'll go and have a look at head, seeing don't really need the sprite renderer unless that's the specific one you want me to look at. And let's go to File, Open Project. So I've got the code here, and I'm just going to go to my D drive and then go to Git and IMT3602 and then 2020 and Carl and Bachelor and oh no, Docs External Report. Okay, I'm assuming it's Bachelor. And then there's sim and test exec. I'll go to sim, and then there's resources and sources. I'll go to sources, and there's nothing there. Okay, what have I missed? Okay, okay, maybe I need to talk to Carl to get the, where is the files that I'm supposed to be looking at. There's something very quiet. Let's turn myself up to full. Okay, what was that? Ah, Thomas. Okay, I can barely hear you, Thomas. I could just hear you. I'll see if I've got an issue with my sound in volume mixer. Why is Discord giving me such low volume? Aha! There you go. Right. Discord, you're now volume high. Okay, now can someone say something? Thomas seems to want to be talking, but user volume. Okay. Okay, anyway, so is it Leon? Are you going to present? Yeah, I can hear you. Right, so what's probably best for me to do for the YouTube people, I'm probably going to have to take off my headphones. This is going to be a wee bit complex. I'll take off my headphones, so you'll speak out through my speakers on my machine. And then what I'll have to do is turn off my own input to Discord so that you guys don't get looping in Discord. Except when I intentionally am trying to talk. Okay, so I'll have to mute myself when you guys talk so you don't get too much feedback. We'll give it a go. I'm not sure how this works. We might as well try it this way. Okay, so Leon, are you going to present?
Sorry?
Who's going to talk? Is it Carl? Because I've got your repo, or who's... Okay, excellent. Okay, so I don't know if the stream can hear you, but hopefully you don't get too much echo when I'll mute myself when you need to present things, and when I need to talk, I'll unmute myself. So if now, where in the repo are we looking?
It's inside Bachelor, and then Sim, and then Source.
Right, Bachelor Sim Source. Right, that's why it's that's why there's no source, is because I'm trying to open a project file, and there's no project file in there because it's just a because I'm actually should be opening an actual file or open a folder
There's a CMake file, which is sort of the project file.
Yeah. So sorry, no, there's just because in Visual Studio when you go open project, it doesn't notice CMake files. So that's fine. Sorry, I should have been looking at the right file type. So under Bachelor Sim Source and select folder. Okay. There we go. Right, and so which file are we going to be looking at?
It's probably application, file system, and window are the only ones that have sensible content.
Right. And I'll just check my... Yep, so that's fine. And then, so if we have a look at that, so let's have a look at application.
You can only see the slides.
Oh. That should change in any second now on the YouTube stream.
Yeah, there you go.
Okay, good. Okay, I've still got myself with full volume on my machine. So yeah, because we're kind of chatting. Sorry about the echo. We'll just have to cope with it. But okay, let's have a look at the application CPP. So if we run down, we have a namespace. Useful to use namespaces. I don't know if everybody knows about namespaces, but basically it's a great way of separating out the scope of functions, so you avoid having to do all those crazy things like saying, oh, I want like all the system functions a double underscore so that they don't get hit by local developers having to do something like run or setup. So what Windows used to do is used to have like underscore setup to say, oh, that's a system one. And then they realized that, wait a minute, there's so many libraries, there are so many interactions between programs, you cannot cope by just adding more underscores to stuff. That doesn't make any sense. And so they introduced the concept of namespaces. It's really good from a sort of separating out when you've got multiple code bases, which functions associate with which code base. Okay, so that's a namespace. Good idea. I like namespaces. And again, you can close it off so you can see, yes, everything's inside the namespace. That's all good. Okay. Right. Okay, great. You're using a while true loop. Do you really need a while true loop?
Well, that's going to be a variable when we get to the variable.
Okay, so you're going to make that a variable at some point. You're going to make that something that I actually set that then ends the program, rather than just...
Yes, for now it's just to have a main loop in the program so we can see the...
Right. Okay, so that's what we would call technical debt, right? You've added some technical debt to your code because you've got some code in there that you have to change at some point, because it is ugly. So I consider the while true as something that you should change, probably earlier rather than later, but because at the moment I have no idea when this ends or how it ends, so I assume there's some sort of exit statement somewhere deep in draw or handle input that quits out of the program.
Yeah, and handle input that's a hard abort, right?
Yeah. Oh, that's so ugly. Okay. I understand. There are some people who use go-tos to do the same sort of thing. It's understandable. I would actually kind of make that loop more meaningful at this stage. Anyway, but pseudocode at the moment. Okay, so handle input, update. You've got a sixth of a second or a sixth of an update.
Yeah.
Magic number with...
because we haven't captured the delta time yet.
Right. Okay, so you haven't captured delta time yet, and so you're just putting in a supposed delta time. Right.
So I would say like starting from the initialization functions and the window class is more like complete and fleshed out, and also the file system.c complete class is more fleshed out.
Right, so I picked the wrong class to harass you about. Yeah, okay, so again, what you do with something like that is you should potentially, even at this stage, you could go, you could do, instead go dt or dtime, something like that, and then do float dtime equals Norwegian keyboard, dtime equals 0.1666. So that's the potential reason to do that. A Clang format file. Okay. Are you using Clang formatting? C language formatting?
Yeah, to follow certain code styles, so
okay.
Set it up together. Right,
so interestingly, Visual Studio has just popped up a warning to me. I don't know if you guys see that on the stream. No, you don't get to see that on the stream. Okay. It popped up a Clang warning saying, I've recognised that I can then tell you if you're following the CLang format. So okay, interesting. I hadn't seen it automatically do that before, but that's a nice feature. Okay, so I would potentially do something like that, or put that further outside the loop so that it's not, in theory, being initialized every single loop. Your optimizer won't care; it will move it outside anyway. But if you put the delta time somewhere else. One of the advantages of doing that is that this now actually looks like what you say here, pseudocode, right? Because you are explicitly saying, stop that movement. I've grabbed a P and it won't let it go. Right. So what you're saying by putting the number in here is that this is no longer pseudocode. That's very quite specific. So if you're writing pseudocode, do try and use the words like update dtime, and then just add the extra line up there. When you go to fix it, it means that you can see that this has some sort of dtime. It is only a temporary one, so maybe you want to kind of have some sort of underscore after it to say, hey, this is a terrifying variable, don't actually use it, and anything with an underscore is a temporary thing, right? So to signify what is technical debt that you need to come back to. Because people might look at their code and go, oh, the 0.1666, that might be a meaningful number. Am I going to change it? Right? And if they say if it's got an underscore after a variable name, it goes, oh, that's definitely something I can change, right? Or update. And so little things like that. Okay, so you're doing sorry about that. So you're using SDL polling events, and there's your abort, as you said, hard abort when you hit the event key. Yeah, fair enough. It's a quick hack out at the moment. You know you're going to fix it. Draw just as a clear display, fair enough. Your initialization has your get initializations, and those are all fairly standard for a GL init. Yeah, you're just following the pattern there. It's what I would expect to see, so that's perfectly reasonable. You don't really even need much commenting on that sort of stuff because it's so standard way of doing things that anyone who knows GL will go, oh yeah, that's just the standard init stuff. And okay, so is there a particular piece of code you'd like me to look at? So you reckon that file system was more well set up? You're using Lua as a scripting language.
Yes.
Interesting. I quite like Lua. It's become less common recently, but it's still fun to experiment with having a separate scripting tool built into the C++ and see how that works between kind of converting C++ functions to be able to be called to look by Lua and having Lua functions be able to be called by C. So that's quite nice to see. I see those are all global. Write file, read file, make directory, move file, file exists, delete file. Those look like perfectly reasonable names. I think I could work out what each of them do from their names, so that's a good indicator that you're using the right kind of names. And yep, logging functions, yep, binding those different functions, that looks good. I'm happy with that. Yeah, no, and then, so as you say, that's less fleshed out than say file systems.
So the file system is probably the most complete one.
Right.
File system does CPP and H. So window is just pretty standard SDL initialization, so it's not very exciting.
Yep. But your file systems are what does so yeah, so you even have in your H you have the overall project namespace, and within that project namespace you have its own file system namespace. So yes, you're doubling up on namespaces to make it extra sensitive to make sure that it sticks within the that you don't have of functions called things like init, which are very clearly could of course be overwritten by other things that want to initialize, and so you do have to know what namespace you're in if you're going to have an init function. So init, that's good. So your physics file system init.
Yeah, it allows you to have separate, like create a virtual file system within your hard drive, so users cannot write outside the directories that you set. That way they can't mess up with the script.
Nice.
Yeah,
yep.
Physical file system.
Physical file system. Right. So physical file, not physics. So physical file system. Right. So it actually, right. So it sets that up. Looks reasonable, and then it does a write and mount. So it kind of creates its own file system on top of stuff and says, haha, this is the limit of what you can do. Yep. No, that looks like a nice way of dealing with writable content, because it's always a challenge when you've got writable content that you don't want to destroy the stuff that's on your machine, and you want to limit the
especially when users can script themselves with Lua.
Yeah. So that can be terrifying to allow any user to actually do some script writing. Okay, so as we scroll through here, I see you're using some nice C++ auto for understanding the bytes, so that whatever comes back from the read bytes is, you don't really care. You just say if it's 0, do something about it. Otherwise, it looks like it's there for an integer if you've got -1. Though I suppose it could be a error condition, or is it number of bytes?
Yeah, -1 or less is error.
Right. Yeah. So it probably defaults back to read bytes as an int, but you know that. Yeah, but you don't have to know that. You can actually say auto and just say, oh, whatever it comes back as I'll deal with, and so long as -1 is an error type, then that's fine. Okay, so that's all good. There'll be some people who would say read bytes is less than or equal to -1. Some people would actually say, well, hey, maybe that should actually be an enum somewhere. So that you enumerate it as a -1, which is like error, so less than or equal to error type, and you just have error type as a -1, because then that if you did need to understand that what it returns, or that it returns something different, then you have 0 as no error and -1 as stream error or read error, just to get rid of some of those magic numbers, right? So that's one of the things you can do, is try and look at making that even clearer. Though, as I said, that's an argument that you could make. Most people wouldn't make that argument, because 0 and -1 is an error has been used so much and for so long. It's very kind of, everyone knows what that does, so maybe you leave it as it is, even if there is a better way, because it's confusing. Maybe it's not a better way, right? So it's yeah.
I would say, like in this case, it's just wrapping another library, and we ourselves could not necessarily use 81 as an error code, because with these either exceptions or enums, as you said, our
But I take it that the physical file system stuff doesn't provide you an enum, because technically what should happen if you're using this return from the physical file system, there should be some sort of physics file system error code header somewhere that would allow you to say, oh, the physical file system has a header, has a static that is error, and so I have, physics file system instead of -1 there. I have the physics file system _ error code or something like that. But
there was one on line 31. They had a get error by code function.
Right. So they do have a log get error by code, get last error code. Right.
So that translates from a number to a string.
Right. So yes, that translates from the -1 to something relevant and interesting, that someone might actually understand what the error was. There might be, instead of the get error by code, I'm thinking that there's probably they therefore have a lookup between things. It might be used. The -1 is so common. It's, as you say, it's another library. You're not really doing it, so the -1 is probably fine. It's just a piece of information that you have to know about to use the library. You could add, some comment on phys fs errors. So that's the kind of comment you could add there, and that might be a useful comment. But it should say, files empty, and here physics errors, and then you actually do the report the error So that's it's fine, right? That's just a stylistic issue. That's not really a good or bad issue. It's just what you prefer at that point. Okay, we'll just read that down. Okay, so let's have a look. We've got write file. If not exist rpath, files does not exist rpath. Okay, those are perfectly reasonable naming. I see you've got the log a log tool that reads the brackets as the single variable, and it inserts that variable into where the brackets are. That's perfectly reasonable.
Same syntax as Python.
Yeah. So that particular log function has been programmed to have Python syntax. So because it's in C, it's not native syntax, but the function has been written that way. So that's perfectly reasonable. Anybody, normal programmers should be able to read that and understand it. You're using a return -1 as a could not write error code, so that is to the write to file function. So are you
returns how many bytes was written, or -1 if there was an error?
Yeah. Well, once you're starting to use -1 repeatedly as an error code, then I would consider whenever -1 is actually being an error, you actually say this is you actually go and create an enum, a macro that is a hash define that is error, right? Just to be clearer, that I'm not actually talking about a -1, which might actually be a number. So it is so the first time I saw it, not a problem. When you start to use it, it's kind of and I see you tested here. Okay, so at that third time, that's when I'd start saying, maybe you do actually want to get it as a defined value rather than just have it as a magic number. Again,
that makes sense.
Yeah, it's kind of where that tipping point is. Okay, so let's have a look now. We got making directory, that's all good. Moving files around, you're passing in standard string view and you're just copying the file and then you try and delete. So move is just a copy followed by a delete, and if copy works, you return true, but you've got these error cases if it fails. So so if copy file returns true, it succeeded, otherwise failed to rename file, right? Yeah, no, that's reasonable. Okay, so and delete file, delete file and copy file. So again, you've got good logging around things failing, perfectly reasonable. With your so there is a question actually going back to move file. Okay, so move file, you don't have any comment around it, but as it currently stands, if it fails to delete the old file and it returns that error, so what does it do when it returns? So when it generates that error, does it just write that error as an error message? Because that's just a log, yeah?
Yeah, that's just a log.
It's just a log saying it didn't delete. So here so there's a question around, is this the functionality you want? If you try and move a file and it fails to delete the original, you now have a copy of it in the new place. Is that the intended fail state of a move, or should it only move if it should it unwind that by doing if I failed to delete the old one, I should remove the copy that I created?
That probably makes more sense, yes.
Right, so yeah, again, it's a like functionality wise is because otherwise, I might try and do a move and then it fails and I think, the move failed, but then I've got this extra copy of the file somewhere. So yeah, for the logic, you might want to have that fail state delete the new file.
I think that's definitely an oversight, yeah.
Yeah. Okay. But of course, you don't want to delete the new one until you know that the old one's still safe. But yeah, that you should know that from the failure of the delete, so that should be fine. If exists are new, okay, so that goes through there, so it copies and then gives you a warning message. If it gets, it returns true if it copied. If it didn't copy, then if exists the new file name, failed to delete new file during renaming. Okay, so copy the file, it will return true. So the only way you get down to the second half of the function is if it failed to copy the file, if it failed to create the copy. And then you check if the rpath new exists, which can't exist because copy file failed. Because we can't be here if copy file succeeded. Am I right?
Yeah, I think the ordering here is that it's not exactly.
Because if the new one exists and you fail to delete the new one.
Yeah. And then if it doesn't copy, then it checks if the new one exists, and then it will delete the new one if it somehow was able to take a copy.
Okay. So let's say I've got okay. So I've got two files called text.txt, right? So just standard text files. And I want to make, and I go, copy it from this file into that other file, okay, into the folder, right? So I'm moving to do different paths. What this currently will do is it will try and copy it. It will fail on the first one, saying, a file with the same name exists where you're trying to copy it to. It then immediately, so it fails on the copy. It then goes, I see there's another file with this name already existing over there. I'll just go and delete that for you.
Yes, that is actually what is happening here.
Yes. So it will delete the other file, even if it's not actually an identical copy of the file you're trying to copy. Just the fact that it exists means it's going to get hammered and deleted with no warning.
Yeah.
Yes.
That needs to be.
That becomes a you're destroying files. That's a bad thing, right? So yes, what I'd do is I understand the intent that you have with this code, which is the idea is that if I had, so realistically this stuff needs to be kind of inside here in some way, more inside the. If I succeeded in copying it and I didn't delete the old one, I then need to go and remove the one that I had just created, right? But at the moment what this does is it goes and destroys anything that happened to be there that stopped me. The other way of dealing with this is if you had an interactive mode, you would then say, hey, are you sure you want to overwrite the file or something like that, right? That would be the interactive mode version. Though if this is in script, it's not interactive, therefore you're not going to give that option, so you just want to basically give an error log saying, well, actually, sorry, you couldn't do that. You're going to have to pick a different file. because that one's already there. Unless you explicitly tell me to delete that file, I'm not going to accidentally delete a file in a move function. Yeah. Okay. So definitely go and fix that. Okay. And yep, no, I'm now up to 130 lines of code. Now, you know, in the thing we say we should only really code review 100 lines of code, but you know, I'm still up for us. Right, are we supposed to see something on the other slides on YouTube, Simon? Oh, okay. Was that an older comment? Yes, so hopefully you guys are seeing this code that we're talking about on the stream. Oh, I'll keep going. Okay, so copying. If it doesn't exist, you can't copy it. You can't copy back into the same place. Fair enough. And then you write the data, write the file, read the file, and then you write the file, and you check the links of stuff you did, and so you read into data, and then you write out that data to the new file location. Okay, reads into memory, then masks it. Yeah, fair enough. So long as you've got enough memory in data to hold it. So long as data can cope with that amount of data, then that's fine. And if you were able to write the right number of data lengths, then yes, it says successfully copied and returns true, otherwise it returns false. Okay, so you're returning true and false from copy file. And alright, if you are using Boolean operators on that. So one of the things, okay, so you're using Boolean operators and returning trues and falses from your functions which are Boolean type. All great. There is an issue when you're combining that with a library that uses 0 as fine and negative, or 0 as a number and -1 as an error, because 0 is false. So you can actually test the truth value of 0 and it will say false, and the truth value of anything else and it will say true. So unfortunately there is, and it is a terrible feature, but hopefully with the fact that you're using bool and it will do strict typing and say, well, you know, that's not a Boolean type, it will still treat those return values of 0 and -1 as integers, and then it will do a test on integers and make assumptions. So so for example here, does physics delete return the kind of error code that the physical file system write does? Does it return 0 for deleted 0, or like 0 bytes, and negative for an error? Or so yeah, that's, so I'm always a wee bit cautious when you have some things returning 0s and -1s for errors and some things using true and falses, because these are quite different types, and they can, if you do this sort of return, you have to make sure that function
yeah, this one returns non-zero on success and 0 on error.
Right, so it's actually returning an integer. Or is it?
But it's 0 on error, so, and everything else is success.
Right, so 0, so false on error. Right. Okay. Yeah. But you understand my kind of
Yeah, definitely, in case it didn't do that. We read the documentation before writing it.
Right. Yes. so yeah, but you can understand why that's always no. It's one of the things that can cause a problem unless you're very careful about it, right? And it may be that you even want to comment something like this, where you're basically converting an integer into a boolean.
Yeah.
Right?
Just to be clear about it.
Just to be clear that you actually know that that's what's going on, and that you are comfortable that the physical file system is going to return you something that can be converted into a boolean. So I'd almost do an explicit cast, just not because you need to, but because it signifies that you know what's happening.
Yeah.
Right? So it's been a while since I've done a cast in, but is it just cast? No.
Static cast.
That's right, it's bool. You do something like that before it? Does that...
Well, it's a little bit delayed for us, so we can't see it.
Okay. I think you do bool like that to statically cast it to a bool. Right? Now,
before we see it, should be static underscore cast and some curly brackets, and then do this around.
Right, I think, yeah. So, but the idea is that you are statically cast. Yeah. So if you explicitly cast it to a boolean, then it tells me, as someone reading this code, you know that comes back as an integer. You know you're casting it to a bool, and therefore you know. Like, then I can go, oh yeah, no, they know what's happening here. I feel comfortable that they've thought about it and they've done the. Yeah, they know what their code is doing. But so so I suppose that's for me, that's a classic part of what I mean by this kind of professional programming side of things, is that we both know that that's not needed there, right? So you know that it will work without the bool, and I know it will work without the bool, without the explicit cast. But by putting it there, I signify to another programmer that I know what I'm doing here, and I'm being explicit about it. Therefore, they don't have to query me as to, do I know what I'm doing? Right? So hopefully the rest of the class can also see that as kind of one of these interesting, right, so it's not about getting it to work, because it was working. It's about that communication with other programmers, that you're explicit about what's happening. So yeah, think about that when you do other things and other bits of code, and all you other programmers, can I, like, when I signal that I know what I'm doing here, is there a way of showing it explicitly to say, actually, I do know what's happening here, and I will not just let it happen, I will say that I know what's going on. So yeah, so that's what I would do there. I won't push this code, so you're going to have to write it yourself as well, but I just like writing. And I just like writing in so you can see what I intend to do. And of course, so we've got this last one, which is the copy file, and yeah, that's returns true when it's in there and returns false when it's down here. If it gets here, it returns false. Yeah. That's because sometimes it likes to have a return at the end of the function anyway. It's just that because you've got a single if before you get to that false return, there is part of me that prefers to do an if and then have the return false and an else to be very explicit about it. But in this case, I think it's okay because it's a copy file, and when you return false from copy file, it's fairly clear that, if something doesn't happen, we're going to say things failed, right? So I can understand why you can have those separated, and the default is that it fails unless something interesting happened. So that's okay. I can understand that works, though. I would. So my question here is that for copying a file, if it creates the new file, let's see. So let's think. What does it do? So it works out like so. This write file function, right? So there's an auto bytes equals write file, and that is generating the new file, and it's supposed to put the data in there. I'm just wondering if that returns a different value, what are the types of fails that it can return, right? Because if write file can return different types of fail, one of the types of fail might be I created the file but didn't write all the data, or so I created a file, so there is actually a file now in rpath, but somehow some of the writing didn't work, or I didn't write all the bytes, or something else failed. At this point, you basically have if it worked, great, return true, and that would be true, because write file will only return the appropriate number of bytes if it actually wrote all the bytes. But in case it returns some other value than all the bytes, you just return false and leave the file system messy. So you don't, at the end of this copy, I don't see a check to see that the new file isn't hanging around.
Right, so we should check if the new file exists and then delete it in case something was written that should not have been.
Yes, yeah, because unless write file only has two possible states, either it completely successfully writes the file and tells you how many bytes it wrote, or it could not create the file at all and therefore returns a fail. If those are the only two possibilities, and if there's never a possibility that it returns anything else than that, then yeah, maybe you could get away with it. But if there is ever the possibility that it fails in some other way, then you would want to do a check here that you haven't just created a corrupted file somewhere, or a half-written file, or a file with 0 bytes in it because it created the file but then couldn't write to it, or something like that. So there are some possibilities that a write file process could fail in other ways than not creating the file. So yeah, you might want to check that. And one thing you could do is you could have an assert that rpath doesn't exist, and then have your whole program crash out if that assert ever fails. But the other option would be to
nicer to like clean up after yourself.
Yeah, check it and then clean up. If you're about to fail, delete anything that you did when you were creating stuff, if it happens to be there. So yeah, again though, you'd have to make sure that it hadn't failed because there was one already there, and so that wasn't one that you'd written. So yeah, no, there are things you might want to check around that, and check if you had successfully created a new file, that it's only the one you successfully created that you're going to clean up after yourself. So think about the various options for how you might do that and what the error codes are for the file system. So that's what I would do. But hopefully so that's me doing a code review from a distance. The main message, static cast ball expression. Okay, that's all good. Thank you people on Discord for actually telling me what I'm supposed to say. But hopefully people listening got that idea of I was reviewing code, talking about what, like, some things were, okay, they're just my opinions, I do this. So some of the other ones were, you should probably really reorder that. That's great. And then we spotted a bug that could have been a bug there. And the other one, which is spotting something that was implicitly happening, that by being explicit, I would be better able to tell future programmers that I understand what I'm doing, right? And that's part of that professionalism. So I really want you guys to take that message away, as well, as to think about how do you communicate with other programmers that you actually know what you're doing, rather than you're just, using implicit things and hoping they work.
Yeah.
Yep. Okay. Are there any other questions or other things you... Well, I mean, it's now 12 o'clock, so you guys have to all head off and grab some lunch, and I should head home and try and get some sleep before my 6 o'clock start. I'm down to 6 hours between now and when I have to wake up, so I'm going to have to wind myself down shortly. But are there any other questions?
I don't think we have anything at the moment, at least.
Okay. Thank you very much for letting us look at your code. And hopefully there's some stuff there that you can put in. Now, remember also, you can, if you write up some of this interaction, so as you have some issues there and stuff you're going to change, write that, so document some of that to say this was a code review, this is what we found, this is how we fixed it. Right? So if you can write that in a professional programming proprog.md file and start recording some of that, that's good documentation for the portfolio assessment at the end of the year or end of semester. Okay?
Yeah, we'll create that file and fill it in.
Yep, just again, document some stuff. It doesn't have to be long documentation, just put some documentation in, and then it just means that you've got it there for the end of year. So when we ask, did you do any code reviews, and you can go, these are the code reviews we did. So yeah, great. Okay, have a great night, everyone.
Should we keep that file updated with our own code reviews later as well?
Yes. Yep. The idea is you should update that with your own code reviews. You could create a code review markdown where you actually did all the stuff about code reviews and just documented some of the stuff in code reviews in there. But I will eventually want a professional programming.md, a prof prog. I've got it in the description of handed that does talk about code reviews. So yeah, either way, put it directly in there or put it in its own markdown and then link to it. I'm happy either way, but do document what you're doing with code reviews. You don't have to go massively deep into it, but document that it has happened and, kind of comment on the major things that you found and that you fixed.
Yeah.
Great. Okay. Have a great night, everyone, and we'll see you next week. And yes, I think teamwork is the next one. I will actually talk about teamwork. I started a file on teamwork in the repo, so I'll keep adding to that during the week, and then we'll talk about some of the stuff that comes from Expert in Teamwork in the 4th year course that is run in NTNU, and also talk about some of the stuff that I do around group work to try and improve the way that you communicate, which is the whole reason we have Agile is just to improve communication. So have a good night, everyone, and we'll see you next week. Okay.
And thank you for the code review.
All good. Hopefully it was useful. Cool. Okay.